Hello students, today we're going to be taking a look at functions and we're going to cover quite a few topics here, but we're just going to cover it very briefly. So this should be supplemental to any other classwork that you do. We're going to start with functions, and the definition of a function is it is a relation where each input only has one output. All right, so we've talked a little bit about what relationships look like. So a relation is kind of a connection between two sets of data. So relation, just add this in case you were not too sure. Connections between two sets of data. So we've seen some examples where you can have certain numbers giving different outputs. Think of it like, we do use the word input and output, so it's almost like a computer program right here. All right, we've talked about how you might have 3 letters that you could type in, and based on the letters you might get a number that comes out. And so we talked about how you might have certain relations, right? We talked about how this would be like a 1-to-1, but then if you have something like this, then it would be maybe, you type in B and you could get a 1 or a 2, right? That would be 1-to-many. And then we could have this right here where we could have many to 1. So that's just a kind of messy little example there, but that's what the relations are, right? So when you input, you might get multiple different outcomes. Now, we're talking about functions where each input only has one output. So in this example that I have here, this is not a good example of a function because it's just a relation. If you need to clarify that, we could look into specifically just different individual functions, but you'll get a lot of examples of these. So now that we have that in mind, the next step is identifying how to represent functions. You could do this in 3 ways: verbally, and I'll give an example of verbally. So verbally is kind of like just a very English way, like you're saying what an equation actually is. So for example, verbally, I could say the final price of coffee is the price of black coffee and, right, so like what I would add, and 10 cents, maybe 10 cents for each additional or add on. All right, so let's say I want a little bit of milk, that gives me 10 cents, or I have to add 10 cents to it, and then if I want to add sugar, another 10 cents, right, so that'll be 20 cents total. So it's that. Now, we could also express this algebraically. I'm going to do an algebraic version of this exact same one here. So we had final price is the price of black coffee, and 10 cents for each add-on. So we have the final price, which is y. I'm going to use the letter y here to make it y equals mx plus b, is equal to, now I'm going to start with actually the 10 cents for each add-on because we're used to y equals mx plus b. So 10, you know what, I'll put this in dollars here. So I'll just put 0.10 times x plus, and then whatever the black coffee is. So black coffee, let's say, is $4. All right, so you see that it's y is equal to 10 cents plus the 4 base dollars there. The last one is you could do it through a table. A table is when you have a list of the x and y values. And so you should be able to kind of see the results here. It's pretty straightforward. You'll have whatever x is, you'll have y. Just do a couple of lines. Let's do it one more. So maybe x is going to be 1, 2, 3, 4, and this could be 7, 6, 2, 1. Something like that. No, that's kind of a weird function there, but it does kind of work because each input only has one output. All right, so one more category that we are going to cover today is just the linear and nonlinear functions. So when we're talking about linear and nonlinear functions, we have to remember that we're still talking about functions. But sometimes they can go in an order, or sometimes they're a little bit more chaotic. So we could phrase it this way. Linear functions are when you have a set pattern or rate of change. A pattern or rates of change can be observed. So this is when you could use something like y equals mx plus b, because you could see that it will just go in a straight line. Like it will be very predictable. It's in a straight line. The more you get in the x-axis, the more you get in the y-axis, for example. However, sometimes you get nonlinear. Nonlinear just means it's a little bit more random. And I will say this is much more like real life, because a lot of changes in real life are not as predictable, right? There is no pattern or no straight line, I guess. Let's start with straight line and let's include or pattern. Or pattern. Observed. So this could be something where you might have a data table that would look like this. It's actually similar to the one that I drew earlier, because there wasn't much of a pattern there. Let's just do that. We have the x, we have the y. Let's say we have 1, 2, and 3. And maybe here we have like 2 and then 4. And you're like, oh, cool, I think I see a pattern. And then suddenly it's like 7, right? So instead of 6. So that would be an example of a nonlinear function. It's not going to be a straight line. It's going to be slightly off, but it's not going to be a straight line. So with that, here are some of the basics of functions. And as we learn a little bit more about it and we try to compare different functions, at least this is the foundation of what you'll need to understand. All right, and with that, that's all for now.